Welcome to the final exam, question number 24, and it says, which of the following statements about steel columns is incorrect? So we're looking for the incorrect one. So let's figure out what's correct and cross it off, and then whatever is the incorrect statement will be the right answer. Alright, remember we're talking about steel. Steel columns. I forgot an N. Close enough. Alright, let's switch colors here. Keep them guessing. Let's go with pink. Alright. A, it says wide flange columns are ideal for resisting buckling. And I would say that is incorrect. I would say more of the H piles are more ideal per se for buckling because they are a little bit more hardy like that, as opposed to a wide flange. It's going to be like this. Obviously, I might be exaggerating a little bit. More thin flanges. When you look at it, this is what? The weak axis. So Y, and this is Y axis. If you look at it that way, you'll see that this does not give very much area away from the neutral axis. And this gives about the same as this, to be honest. Because that everything that's right on that neutral axis barely gives any. It's not going to give, because remember that the I and R is this over A. I think R equals square root of I over A if I'm remembering my equations correctly. And since it has I in there, you want the larger the I, the better. So you want as much area away from the neutral axis as possible. And obviously, you might have a high A because let's say you have just a huge block of steel, or it's just a huge square of steel. It's a giant waste of money. It's just let's say it's a 4 foot by 4 foot block of just a ginormous piece of steel. And sure, it has a decent I, but the A is pretty darn big. Now, on the other hand, look at the XX A for a wide flange beam is really good. So if you had continually braced in the weak direction, let's just say weak and strong, in the weak direction, it wouldn't buckle this way that easily. So yeah, I guess a wide flange beam could be good. But in this is the R's are closer. The RX, the RXX, and RYY are closer. Are closer for H piles. All right, that's enough of the instruction that I'm going to do. So I believe that's the correct. I'm going to say that differently. I believe that is the right answer. Let's go ahead and circle it. I believe that's incorrect. I do not think a wide flange beam is the most ideal, just because of what I explained. It's really, wide flange beams are bad for the cost, since they're really good in this direction. They won't buckle, but in this direction they have a high RXX, but they have a bad RYY for the cost. H piles are better for columns. But I'm not 100% sure about that, because you could justify, sure, in the right situation, a W flange beam would be ideal. But I would say not in general. Let's go on, though, and just double check our answer. B, the maximum slenderness ratio is permitted, or ratio permitted is 200. And let's once again, off the top of your head, you're probably not going to know that. If you have a steelbook, you can go check through that and see what you think. Knowing what I know, that's the correct answer. And then That is a right answer, sorry. The K factor is used to convert the actual length of the column to the effective length. The K factor is used to convert the actual length of the column to the effective length. That's a right answer. It's a correct answer, so it's not the right answer to our problem here. Because the K, remember, let's assume you haven't seen anything. The K is the effective length. I think for pin, it's K equals 1.0, and this is always the example I'll give you. But if you have fixed free, if you look at it like this, the K effective, if you were to go like this, see how it's the same shape as that now, but the length is twice. So the effective length is 2.0. The K is 2.0, and the effective length is going to be twice as much. And once again, I'm not going to go into that right now, but that means that C is our correct answer, and therefore it's not what we want. All right, D, the buckling tendency of a column is independent of its yield point value. KL over R is kind of the buckling tendency. It has nothing to do with FY, yield point. All right, or the yield strength, but so that is also correct. It has nothing to do with it. It says the buckling tendency of a column is independent of the yield point value, and that's also correct. So as you can see, A is your only incorrect answer, and therefore it is the answer we want. And A is the answer for number 24. I will see you on question number 25.